All right, folks. Well, this is lesson 4, dealing with more than one type of exponent and expression, and I see it and I go, typo, a different type of variable. That's what we're looking at in this one. So let's come through here and let's just simplify. What does simplify mean? Well, simplify means that you kind of clean up the problem like you would a dirty room. Does that sound right? So do we have more than one coefficient in this one? Yeah, of course we do. We've got the 4 and we've got the 3. So what's 4 times 3? So it's 12. And that's the reason I'm putting the coloring in there so you can go, oh yeah, 4 times 3 is 12. So you can follow it. Now, here's the other thing that's happening though. We've got an x right here, don't we? And don't we have an x to the what power right here? To the third. So I'm going to just write down 4x to the first underneath it. Mainly so you guys can understand that, yeah, if you don't see an exponent, there's always a 1 that's there. And so, hey guys, what is 1 plus 3? 1 plus 3 is 4. And so now I'm going to color that so that we can go, oh yeah, the x's go together. Now, if I was cleaning up a dirty room and I had dirty plates, I would put all of my dirty plates in the kitchen, wouldn't I? Maybe the dishwasher, the sink. And if I had dirty clothes, I wouldn't put my dirty clothes in the sink. That'd be crazy. I'd put all of my dirty clothes in the hamper, the laundry basket, wherever your spot is for dirty clothes. Well, you can't put food with dirty dishes. I'm sorry, you can't put clothes with dirty dishes, can you? Well, you shouldn't put X's with Y's. Does that make sense? The X's and Y's are different, so you need to have a different location for the Y's. And so as a result, you're going to occasionally see this. You're going to see, okay, if that's a Y, well, that's a Y to the second times Y to the what? Fourth. That'd be Y to the what? Sixth. Do I have any negative exponents in my answer? No, so we're good. Okay? So we treat it the same way. It's just now you have to really pay attention to that letter, that base, because if it's different, you can't just add all the exponents without thinking. You got to be like, do they have the same base? Do they have the same letter? Now, let's go and let's work through this one. Hey, what are my coefficients on the second one right over here? 5 times 3 is what? 15. Cool. Well, I've got a G here, and it's a -3. No worries. And I've got a G here. It's a -2 exponent. What's -3 plus -2? Negative what? 5. And we'd write that down just normal, correct? Um, the last thing that we have here is the h's. H to the 10th plus h to the -3rd. That'd be h to the what? Yeah, I was going to say, I thought I heard it back there as 7. I used blue there. I guess you could have used red just as easily. Is that a good final answer for us? No. Now out of the yellow, the green, and the blue for the answer, the coefficient, the G, and the H, do we have any negative exponents? It's the G. So what jumps across? Just the G. So I'm going to just, like, I'm out of space here. I think you guys have enough space. You can keep going to the right, don't you? So I'm out of space here, so I'm going to have to come down here a little bit, and I'm going to be like, well, here's the 15, and here's the h to the 7th sitting on top nice and free, and here's my g going down to the bottom, but that -5 becomes a +5. And then if you want to just make sure that you put some color on there just to kind of follow it all the way through, that's fine. But that's what I'm needing to teach you for this lesson. It really wasn't anything new, was it? And so I don't want you to overcomplicate this. I don't want you to overthink this. But we are allowed to have more than one type of variable in these expressions. And it's just like cleaning up your room. You've got dirty laundry, you've got food, you've got trash, you got 3 different things, you've got 3 different places you need to put it. And then once you pile them all up, you can do a little inventory account. Well, I had 17 pieces of trash, and I had 16 plates, and I had about 562 shirts that were laying on the floor, right? Well, now let's take a look at this. Hey guys, sometimes the bases are not variables. If I had x to the third times x to the negative fifth, wouldn't that be x to the negative second? Yes or no? And then we would have to make a fraction, and the x would jump downstairs, and the negative 2 would become a positive 2. Well, who's left upstairs if it doesn't show anybody's left upstairs? The number 1. This person's just like the loudmouth that nobody wants to be around, I guess. I don't know. Whatever story you want to put in there. Well, what happens if we don't have an x, but we have 6 to the third times 6 to the negative fifth? What would that be? 6 to the negative second, right? No, seriously, does that make sense right there? I mean, look, do we have the exact same base? Does that have a 6 and does this have a 6? Do they both have exponents? So what's 3 plus negative 2? I'm sorry, 3 plus negative 5 is negative 2. So now we're like, okay, well, 6 is not happy there. Move it downstairs, 6 to the second power, right? Who's left upstairs? 1. So it's just like the x's. Now, the one caveat is, and this is what the question had while I had it paused, was, hey, do we go ahead and do 6 times 6? It's 6 to the second power. What's 6 to the second power? It's not 12. It's not 12. It's really not 12. It means 6 times 6, which is what? Well, for something small and easy like this, I would prefer you to go ahead and figure it out. But now I'm going to tell you this right now. If I had like 6 to the 8th power, I really don't care about you figuring that out without a calculator. Okay, so if it's to the second or to the third power, I'd like you to go ahead and figure out what it is. So 6 to the negative second power is really 1 over 36. Question: 6 to the negative second power is equal to a fraction, 1 over 36. So here's the question: is my fraction positive or negative? It's positive. So the negative exponent does not make the number negative, it just makes it teeny tiny small, huh? It's another way of writing a fraction, guys. That's what all of these negative exponents are. It's just another way of writing a fraction. Now, when you come up here to the top, and you see that this g to the negative fifth power, it's really just a fraction, something over that g to the fifth on the bottom. So that's what the negative exponents are. It's just a way of writing a fraction. And it's kind of weird, isn't it? But it does have some advantages that you will see play out over the next few years in algebra and algebra 2. So let's go through and let's do our very last one right over here, guys. I'm going to pull this down just a little bit here, okay? Hey, guys, our coefficients, do they actually have exponents on them now? So now they're bases. That's fine. We have the same base of 10, so there's 10. Hey guys, what's 4 plus negative 9? Is that okay for a final answer? No, you can't have a negative exponent. So now we're just going to put a 1 on top, and the 10 falls down, and it's 10 to the what? Fifth power. Now look, I just said that if it's like to the second or third power, yeah, I'd want you to go ahead and figure it out. Do I care about if it's higher than that? Not really, but for the notes, can we go ahead and put it down for the notes? So honestly and truly, it would be 1 over 100,000. Because 10 times 10 times 10 times 10 times 10 has a 1 with 5 zeros after it. I mean, you might remember that little shortcut, and that's kind of nice. And again, that 10 to the negative fifth power, it's not a negative number, it's just a way of writing a fraction. 1 over 100,000. So are you guys ready to jump in and try this, or you got some questions? All right then, at that time, it's that time then. Let's go ahead and just jump into the work. And remember, ask for help if you need it. From me, a friend, that sort of thing, but let's keep it nice and quiet and focused, okay?